Alright guys, so what we're looking at right now for this week, at the very least, we are talking about improper integrals. So an improper integral is, there's a couple different kinds that we're going to look at, but in this video we're looking at integrals that have one of the bounds as infinity. So if we look at the graph of 1 over x squared, we can see that from 1, what we're doing, we're taking the integral from 1. So we're trying to find, from 1 to infinity, we're trying to find the area under the curve. So the problem with this is if we know anything about 1 over x squared, this is going to be approaching the x-axis but never touched. So the x-axis is an asymptote. So we need to think about, is it possible to get an area under a curve that never closes on one end or two ends? So the answer is sometimes yes and sometimes no. It just depends. So I'm going to walk through the process to figure out how you tell. So the first thing we want to do, we're going to combine the idea of an integral and the idea of a limit. So we're going to want to rewrite our integral as limit of, as b approaches infinity, of the integral from 1 to b. So we're replacing that infinity with a b. So once you get good enough at this, this is just what you're thinking about. You don't have to really do it. So we have 1 over x squared, or we can rewrite it as x to the negative 2. So that's what we're thinking. So now we can just go ahead and run through the integral. So we can think about what the integral of this would be. So the integral of that would be a negative x to the negative 1 from 1 to b. Okay. So we have we still have the limit out here. Now we can just go ahead and plug our values in. So we can change this back to negative 1 over x. Probably be a little easier to see. So we have negative 1 over b and minus negative 1. So I'm going to add that over 1. So if we run the limit of our answer, so as b approaches infinity, that first fraction, so negative 1 over infinity, so a really, really big number on the bottom means we're approaching 0 here. So the answer is going to be 1. So the fact that we get an answer, a finite answer, means that this does indeed have an area under the curve. So the area under this curve, and we call this converges. Okay, if we get a finite value, it's convergent. Oops. So convergent. Okay, so in a situation where we don't get a finite value, so we get infinity or something else, we call that divergent. So convergent means it converges to an answer. Okay, diverges means it just keeps growing further and further away from each other, essentially. So we'll talk a little bit more about that later on in some other videos and in later in the unit. So this first one, we're going to have that as an answer. Okay. This one here, we have a velocity problem. So we have velocity of a car is given. So in this situation, you let off the accelerator, so you're letting off the gas pedal, and from the time you let off to an infinite amount of time, we need to figure out what the displacement is, or how far the car travels after you let off the accelerator. So this equation is given to calculate that very thing. Okay? After a certain amount of time, what is the velocity of the car? So we're going to go ahead and set up an integral from 0, so the instant I let off the accelerator, to who knows when. We want to see if the car stops, or does it keep going. Okay, so the equation here, so we're going to do the same exact thing. We're going to replace our infinity with some variable. We're going to use b again. Does it really matter? No. So we have limit from 0, or of the integral from 0 to b of our equation. So if we integrate this, we need to go backwards. We have, if we pull the 100 out, and then we can divide by -1/10, you end up with -1000 e to the -0.1t, evaluated from 0 to b, and then we're going to run the limit of that. So don't forget your limit. Okay. So go ahead and plug those values in. We have, and I'm just going to make this go to the bottom because it's a negative power. So we have 0.1 e to the 0.1t in the bottom of the fraction. We can rewrite that right now if we want. I'll do that right over here, just so you can see it. You don't have to write it. So we have -1000 over e to the 0.1t. Just makes it easier to see what the limit's going to be when we have it in a fraction like that. So if we go ahead and plug our values in, we have limit b approaches infinity for, if we plug in b, we get -1000 over e to the 0.1b minus a -1000, so that's going to turn into addition. 1000. If I plug 0 into the power, we get e to the 0, which is just 1. So now if we run the limit, so we put infinity in here, so e to the infinity, if you remember e, the graph of e, as we approach infinity on the x-axis, we're going to approach infinity. So we have -1000 over infinity, so this thing is going to approach 0. So the limit ends up being just this 1000. So we have a finite answer. So this integral would give us 1000 as an answer. So this is convergent, or converges. It converges to 1000. So that means we have an answer for this integral. Alright, so I'm going to make another video here on some other problems and some situations for this part.